Welcome guys, welcome to Elite Math Studio. Today we will actually be doing secondary 1. The first topic is what we call as prime numbers. So in this topic we'll know what is prime numbers. Okay, we'll know what is prime numbers, prime factorization, the technique of knowing what is highest common factor, lowest common multiple, perfect squares and perfect cubes. Okay, let's start the lesson. Okay. The first thing of this lesson is actually to know what is actually prime numbers and composite numbers. So our prime numbers are actually numbers which only can be divided by the number itself and 1. So for example, prime numbers, we can be what? 2, because it can only be 1 times 2. 3, because it can just be 1 times 3. And then it can be what? It can be 5 as well, because it's 1 times 5. Now, a few other examples of prime numbers. It can be, for example, 13. Why? Because 13 is actually 1 times 13. The other one says actually maybe 31. 31, which is equals to 1 times 31. There are no other factors than 1 and 31. However, let's say for another example, 8. Is 8 a prime number? It isn't a prime number. Why? Because the factors of 8 can be 1 and 8, and also it can be 2 and 4. So for this example, because there are more than 2 factors, so 8 is actually not a prime number. So what number is actually 8? What number is actually 8? 8 is what we call as the composite numbers. Composite numbers. They're actually what we call as composite numbers. Okay, so prime numbers are numbers which only have factors, the number itself and 1. The number itself and 1. Okay, so other than, if it's not a prime number, then it will be a composite number. Some examples of composite number, it can be 4, because it can be factors at 1 and 4 and 2. 6, 1 and 6, because 1 times 6 is 6, and 2 and 3 are factors of 6 as well. So that's the difference between prime numbers and composite numbers. Okay, so for this one, write down all the prime numbers of 20. So what's the smallest prime number? The smallest prime number should be 2, followed by 3, followed by 3, followed by 5, followed by 5, followed by 7, followed by 11, followed by 13, followed by 11, 13, 14 isn't, 15 isn't, 17. Last but not least, 19. That are all the prime numbers. These are all the prime numbers from 1 to 20. Okay, the next one, what are all the composite numbers from 1 to 20? So smallest will be 1. As long as it's not a prime number, it will be a composite number. 1, 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, and 20. These are all your composite numbers. Okay, so as long as it's not a prime number, it will be a composite number. Okay, let's go on to the next page. Next one, we need to know the concept of prime factorization. Prime factorization. There's 2 ways of doing prime factorization. One of which is actually what we call as a factor tree. Okay, so factor tree, let's say the question for is express 54 in terms of its product of its prime factors. So for example, you list down 54 first. Okay, if I were you, I'll go and write down maybe the first 5 prime numbers out on the side. So for example, it will be 2, 3, 5, 7, 11. Okay, so what's the first step? You take 54, divide by 2 first. Is 54 divisible by 2? Yes, so we'll draw like that. 2. What's 54 divided by 2? 27. Okay, then 27, you break it up again. Can 27 divide by 2? No. So we take 27, divide by what? Divide by the next prime number, which is what? 3. So you write here 3. You divide, so it becomes 9. Is 9 divisible by 2? No. Is 9 divisible by 3? Yeah, so write 3 again. So it's 3 here. So we go again. Is 3 divisible by 3? Yes. So we only stop here. Okay, so how do you express 54 as its product of its prime factors? This is what I need to do. You look at working, so it should be this, 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 and this. So you should write as 54 is equals to, how many 2's are there? 2 will be 2 times, how many 3's are there? 1, 2, 3. So it becomes 3 to the power of 3. 3 to the power of 3. So you must ask me, what do you mean, for example, what do you mean by 2 to the power of 2? 2 to the power of 2 means just 2 times 2. What do you mean by 2 to the power of 3? 2 to the power of 3 will becomes 2 times 2 times 2. Okay, that's what we mean by 3 to the power of 3. 3 to the power of 3 means 3 times 3 times 3. Okay, well, one of the methods doing prime factorization is what we call as the factor tree. But the method actually I'll recommend to you guys is actually this, what we call as the ladder method. The ladder method actually, in my opinion, is actually much faster. So same thing, how do I express 54 as a product of 4 prime factors? So what you do is actually we list out first. So it can be like that. So write 54. So ask yourself, first thing, write out first 3 prime numbers. 2, 3, 5, 7, 11, 13. So first step, we take 52. 54 divided by 2. What's 54 divided by 2? 27. Next step, take 27. Can 27 divided by 2? No, we take 27 divided by 3. Becomes 9. Can 9 divide by 2? No, you take 9 divided by 3, which becomes 3. So it's actually 3. Can 3 divide by 2? No. Can 3 divide by 3? Yes. So you only stop upon 1. So how do I express 54 in terms of its prime factor? So just 54 equals to 2 here times, how many 3's are there? 1, 2, 3. So write 3 to the power of 3. That's it. Okay, can? So the next example, I want you to try to express 1800 as a product of its prime factors using the ladder method. That's actually the method I recommend, the ladder method. Okay, let me start a few steps, then you guys continue. So first step, remember, write down the first few prime numbers to help you. 2, 3, 5, 7, 11, 13, so on and so forth. So draw this one first. 1800. Can 1800 divided by 2? Yes. So use a calculator. 1000 divided by 2 is actually 900. Can 900 divided by 2? Yes. Because 450. Okay? The rest, I want you guys to do it yourself. Okay? Can? So let's go to the next one. So what's the purpose of us doing prime factorization? There's actually two other applications. Actually, first thing is actually what we do is actually to find out the highest common factor. The other one is actually to find out the lowest common multiple. So how am I supposed to use the ladder method to find a HCF? HCF is actually the short form for highest common factor. LCM is actually the short form for lowest common multiple. So let's try this one. Find the HCF and LCM between 168 and 216. So this is what you do. First step, same thing, I'll draw a ladder first. And then write 168 and 216. Okay, next step, I write the first few prime numbers as 2, 3, 5, 7, 11, 13, so on and so forth. First step, you take 168. You ask yourself, can both 168 and 216 divide by 2? Yes, so write 2. So 168 divided by 2 is actually 84. 216 divided by 2 is actually 108. Can both numbers divide by 2 again? Yes. So what it becomes? 42 and 54. Can both numbers divide by 2 again? Yes. So it becomes what? It becomes 21 and 27. Can both numbers divide by 2? No. But now, can both numbers divide by... Sorry, pardon me. So, can both numbers divide by 2? No. However, both numbers here can divide by what? 3. So we divide by 3 now. So it becomes 7 and 9. Is there any more common factors between these two? No. So where's our HCF? Our HCF will be this. Okay, so you write here HCF. Highest common factor will be, how many 2s will there be? How many 2s are there? 1, 2, 3. So you write 2 to the power of 3 times 3. That's the answer. If let's say the question asks you to express your answer in terms of what? In terms of prime factors, this will be the answer. If the question just asks you to find the highest common factor, what you need to do is actually go and work it out. We got 2 to the power of 3 is 8. This will be 24. Next step, how am I supposed to find LCM? So let's go back to the working itself. Now there's no more common factors. There's no more common factors between 7 and 9 now. So what we do now is actually to concentrate on just one single number. Let's concentrate on 7. Okay. So ask yourself, can 7 divide by 2? No. Can 7 divide by 3? No. Can 7 divide by 5? No. But can 7 divide by 7? Is 7 divisible by 7? Yes, it is. So take 7 divided by 7. So just concentrate on 1 by 1. 7 divided by 7 is divided by 7 here. So it becomes 1 and 9. So once you reaches 1, you stop. Let's concentrate on next number. We'll concentrate on 9 now. Can 9 divide by 2? No. But can 9 divide by 3? Yes. So take 9 divided by 3. Becomes 1 and 3. Can 3 divide by 2? No. Can 3 divide by 3? Yes. So you write here 3. So we stop. Because both numbers are 1 now. So how am I supposed to find the HCF? And now how to supposed to find the LCM? So find the LCM is actually this whole thing. This whole thing will be our LCM. Okay? So what's the answer? Same thing. How many 2s are there? How many 2s are there? Let's do 1, 2, 3. So it's 2 to the power of 3 times. How many 3s are there? 1, 2, 3. So it's 3 to the power of 3 times 7. Okay? Let's say the question asks you to express in terms of product of its prime factors, this will be your answer. If the question didn't say anything, asks you to just find the LCM, so you have to calculate it out. So it will be 2 to the power of 3 times 8 times 27 times 7. So answer will be 1512. Okay? So that's how we use ladder method to find our HCF and LCM. Okay? However, there's actually another method. Another method is actually to express 168 in terms of prime factors and express 216 in terms of its product of prime factors, and then you compare it. What do you mean? Maybe I'll try it once for you. So write 168. So first thing, for our first few prime numbers, 2, 3, 5, 7, 11, 13, 17, so on and so forth. So write 168. So can 168 divide by 2? Yes. So right there. Divide by 2 is actually 84. Can you divide by 2 again? Yes. 42. Can you divide by 2? Yes. Becomes what? 21. Can you divide by 2? No. So we have to do next one. Divide by 3. So it becomes 7. Divide by 7. There's actually here 1. So 168. So 168 here will just be equals to 2 to the power of 3 times 3 to the power of 7. Okay, next step, do likewise for your 216. Do likewise for your 216. Can 216 divide by 2? Yes, so it becomes 108. Can 108 divide by 2? Yes, 54. Can you divide by 2? Yes, 27. Can you divide by 2? No. However, can you divide by 3? Yes. 9. Divide by 3 again. 3. Divide by 3 again. 1. So, 216 will be in terms of 2 to the power of 3 times 3 to the power of 3. Next step, you're going to write 168 and 216 on top of each other. So how am I supposed to find our HCF? Okay, this is a technique. To look up for the HCF, we take the lowest power. Lowest power. Lowest. You look up for the lowest. You make a direct comparison and look up for the lowest power. Okay, so let's see first. So let's see. 2 to the power of 3 and 2 to the power of 3. Which base has actually, with the same base 2, Which one has the lowest base? Lowest power. Apparently both the powers are the same, so that's why we choose 2 to the power of 3 here. Okay, next one, we are comparing 3 to the power of 1 and 3 to the power of 3. Where's the lowest base? Lowest power. The lowest power is actually 3. The next one, we are comparing 7 and is there any base 7 here? No. So we're comparing 7 and nothing. Which one is actually the lowest? We take nothing. So what's the answer here? The answer here will be 2 to the power of 3 times 3. So we're going to work it out. It's actually 24, which is actually the same as the previous one. 24, 24 and 24. Okay, so how to find LCM? If let's say the HCF is actually look out for the lowest power, the LCM we should look at the what? We should look at the highest power. Highest common factor, we look out for the lowest power. Lowest common multiple, we look out for the highest power. Highest power. Okay, so look out for the highest power. Look out for the highest power. Okay, so same thing. Let's inspect. 2 to the power of 3 and 2 to the power of 3. Which one has the highest power? Both the powers are the same, so that's why we take 2 to the power of 3 here. Okay, next one. 3 to the power of 1 and 3 to the power of 3. Which one has the highest power? 3 to the power of 3. Okay, the next one. 7 and nothing. Which one has the highest power? 7. Okay, so you're going to work it out. The answer will be what? 1512, which is exactly the same as the previous one. 1512 as well. Okay, so you may ask me, which method should we use as examinations? I think the fastest way is actually this method. The first one, the ladder method. The ladder method, you should use this. However, let's say the question gives you, if the questions, However, the question really gives you the numbers in terms of prime factors like that. If it really give you numbers in terms of prime factors like that, we just make a direct comparison of the powers. That would be the fastest way. So, for you guys, you must go and learn both methods. Both methods. Okay? Can? Okay? Now, it's the same thing. Now, instead of doing 2 numbers, now we are comparing against 3 numbers. So how am I supposed to find the HCF and LCM between 3 numbers? Let's try. I'm going to demonstrate once for you. Same thing. First, write down first 5 prime numbers. 2, 3, 5, 7, 11, 13, so on and so forth. Okay, so draw it out first. Okay, so write 168, 216, and 272. Okay, first step. Ask yourself, between 3 numbers, can you divide by 2? Yes. So it becomes 84, 108, and 136. Can all these 3 numbers divide by 2 again? Yes. So it becomes 42, 54, and 68. Can these 3 numbers divide by 2 again? Yes. So it becomes what? 21, 27, and 34. Is there any common factors between 21, 27, and 34? There isn't. So what's the HCF? The HCF will just be this. Here, the red box here. So if you express it out, it will be here. 2 to the power of 3, which is equals to 8. So how are we going to find our lowest common multiple? We're going to carry on. So instead of doing is focusing on one numbers, after we are done with all the 3 numbers, we focus on 2 numbers instead. 2 numbers instead. So let's focus on 21 and 27. Any common factors? Yes, there's a common factor of 3. So write 3 here. So it becomes 7, 9, and 34. Any more common factors between 7 and 9? No. How about 9 and 34? Also no. How about 7 and 34? No as well. So now we concentrate on one number each. 7, we divide by 7 here. So it becomes 1, 9, and 34. We concentrate on 9 again. So it becomes 3. Becomes 1, 3, and 34. Divide by 3 again. So it becomes 1, 1, and 34. Okay? Then after that, we consider 34, divide by 2 again. So it becomes 1, 1, 17. Divide by 17. 1, 1, 1. So what's my LCM? It's actually this whole thing. This whole thing. Okay? So we go in. If you go in, see the result. How many 2 will there be? How many 2's are there? How many 2's are there? B 1, 2, 3, 4. That's why our LCM here is actually 2 to the power 4. How many 3's are there? 1, 2, 3. So that's why in the answer here is actually 3 to the power 3. Then 7 will be 1, just 1 here. And then the last one 17 will be just 17. Okay? So that's how you do HCF and LCM between 3 numbers. So you make direct comparison between 3 numbers first, 2 numbers, and then 1 numbers. Okay, the HCF is you only stop the HCF, you only find the HCF when there are no more common factors between these 3 numbers. For LCM, you need to go on. Okay, the next one is this one. You're supposed to find HCF and LCM between 168, 216, and 272. So what I need to do the other method, remember, is actually to what? To express each of numbers in terms of prime factors. Okay, so let's say the working will be 168, and prime numbers will be this one. 16 is this, and 272 is this. Okay, so how am I supposed to find the LCM, HCF of this? I hope you guys still remember how to find HCF. HCF, we look out for the what? The lowest power. The lowest power. So we look at this. So between the same base, 2 to the power 3, 2 to the power 3, and 2 to the power 4. Which is the lowest power? Will be 2 to the power 3. So that's why it's here, 2 to the power 3. Now we compare base 3 instead. Base 3 instead. 3 and 3 to the power 3. Okay? 3 and 3 to the power 3. For this one, 3 and 3 to the power 3. What's the answer? What's 3, 3 to the power 3, and nothing. So what are we comparing? Which is lowest? 3, 3 to the power 3, or nothing? The answer is just what? Nothing. So for this one, there shouldn't be anything here. Now we compare base 7. This base 7 here, any base 7? No, no base 7. So we take nothing. Okay, the last one, this 17. And is this base 17? Any base 17 here? No. Any base 17 here? No. So we take what? Nothing instead. So what's the HCF? The HCF will just be 8 to the power 3, which is equals to 8 here. Okay, how about the LCM? LCM, I hope you guys remember, LCM took out from the highest power. So look at base 2 first. Base 2 are all the ones with the red circle. Between 2 to the power 3, 2 to the power 3, and 2 to the power 4, which is the highest? The answer will be 2 to the power 4. Let's look at base 3, which is all the blue circles. 3 to the power 1, 3 to the power 3, and nothing. The answer will be 3 to the power 3. The next one, look at base 7, which is all the green circles. 7 to the power 1, nothing and nothing. So hence we take nothing. Sorry, not nothing. We take the highest. The highest will be what? 7. Because highest, lowest common multiple, we look out for the highest power. Okay, last but not least, we look at 17, which is the black circle. 17, nothing and nothing. We need to take the highest. That's why we take 17 here. So the answer is just this. Okay, so what I'm trying to say is actually that you need to know both methods. Either you express each of them in terms of what? Prime factors. Either express each one of them in terms of prime factors, or you're gonna just do ladder method on it. Okay, between 2 numbers and 3 numbers. Okay, this is what you need to do. Okay, on the next page, I'll actually give you some examples and exercises. Please go and try it. Pause the video and go and try it. Any problems, please revert back to the previous example. Okay, for this one, the question never state any certain methods. So what you need to do, I think you would do the most preferred way, as I told you, will be using the ladder method. Ladder method. Okay, can. Let's move on. Next page. On next page, I also did. Okay, so let's try this one again. It's given that A is actually 2 to the power 3 times 3 to the power 3, A to the power 3 times 3 to the power 3 times 7 to the power 2 times 3 to the power 2. B is this. Find a HCF and LCM within this. Okay, HCF, LCM. So let's try to find HCF. HCF, I hope you guys remember, we look out for the lowest power. Lowest power. 2 to the power 2, 2 to the power 3, 2 to the power 2, which is the lowest power? 2 to the power 2. Times, let's look at the next one. We look at 3 to the power 3, 3 to the power 2, and nothing. So which one you take? You take nothing. Next one, 7 above 2, we look at base 5 first. 5 above 2, nothing and nothing, because there are no base 5 here, so we take nothing. Next one, we look at base 7. 7 above 2, nothing, and 7 above 3. Which one you take? We'll take nothing as well. Okay, the next one, 11 above 2, compare against nothing and nothing. Because there's no base 11, so it's nothing, so we take nothing as well. Last but not least, we compare base 13. 13 above 2, 13 above 3, and 13 above 5. Which is the lowest power? 13 above 2. So the answer will be this. The question wants you to express the answer in terms of prime factors. This will be the answer. Else, go and find it. Next one, find me the LCM. So LCM, lowest common multiple, we look out for what? The highest power. So go and compare. The base 2 are all in the circle, the red ones. So which one is the highest power? The highest power will be 2 to the power of 3. Times, we look at all the base 3. All the base 3 is actually what? All the base 3 are all the blue color one. The highest power will be 3 to the power of 3. Times, look, compare base 5 now. Base 5 are all the green color circles. The highest power will be 5 to the power of 2. Times, look at base 7 now. It's all the yellow circles. The highest will be 7 to the power of 3. Times, now we look at the base 11, which is the black circle. The highest power is 11 square. Last but not least, we compare base 13, which are all the pink circles. The answer will be 13 to the power of 5. Okay, can? So the next one is actually an example for you to try. Pause the video and go and do it yourself. Remember, HCF is actually the one with the lowest power. LCM, we're looking for the highest power. Same base, lowest power. Same base, highest power. Next one, we're going to find HCF and LCM in problem sums. Let's read first. A rectangular board measures 126 by 162 cm and is being cut to squares with no leftover cardboard. Find the largest possible length of this. So first step, you draw a rectangle right here. So write 126 and 162. What I need to do is actually try to cut these cardboards into what? Squares. So what's the question asking you? You're supposed to find the largest possible length of the square, which is this one. Okay, how are you going to do? Let me ask you, is the length of the square going to be bigger than 162 or smaller than 162? Definitely, if you look at the diagram, the length of the square must be smaller than what? 126 and 162. So let's say we're trying to find a number which is smaller than 126 and 162. We are trying to find what? Are we trying to find the factors or multiples? The factors. So the question is indirectly asking you to find the what? The highest common factor between 162 and 126. So same thing. So we do the ladder method as I told you. That's the fastest way. List out all the prime factors. 2, 3, 5, 7, 11, 13, so on and so forth. Okay, so they take 126 divided by 2 first, which is what? 63. 162 divided by 2 is actually 81. Can both numbers divide by 2? You don't remember divide by 3 now, which is what? 21 and 27. Divide by 3 by both is actually equals to 7 and 9. So what's the HCF? The HCF will just simply be this one. The HCF will be this one, which is equals to 2 times 3 square, which is equals to 18. Okay, next one. So we know the largest possible length, this one is actually 18, so write 18 here. The question is how many subsquares can we cut out from this? So what's the next step? We just take 126 divided by 18 is actually equals to 7, and then take 162 divided by 18 equals to 9. So what do you mean by 126? Why do you need to take 126 divided by 18? We are trying to find how many squares can you put along this breadth. And what's the purpose of me taking 126 divided by 18 on the second step? It's actually to find how many squares can you put along this length. So we know that we can put 7 squares on the breadth, and we can put 9 squares on the length. So how many squares would that be? Each row there are 9 squares, there are 7 rows. So answer will be just 7 times 9. Okay, the answer is just 63. That's answer. Okay, can? So same thing, next question, I give you this. Go and try it out. Just have to ask yourself, are you trying to find an answer that's bigger than 180? Sorry. Are you trying to find a number that's bigger than 180, 216, 228? Let's say your answer is actually supposed to be bigger than all these three, so you are trying to find the lowest common multiple. Let's say you're trying to find a number that's smaller than this three, you're trying to find the highest common factor. Okay? Go and give it a try. And next one, let's try another one. There are 3 bells in the school. Bell A gonna ring every 30 minutes. Bell B gonna ring every 45 minutes. And bell C trying to ring every 60 minutes. If all the 3 bells gonna ring at 1100 hours, when will be the earliest time all the 3 bells will ring together again? So this is the time. This is what you do. So you ask yourself, bell A will ring every 30 minutes. So means bell A will ring 30 minutes. Next time will ring will be the 60 minutes because it's multiples of 30. How about B? It'll ring 45 and then what? 90, 135, so on and so forth. C, 60, 120, 180, so on and so forth. So you can see what I did here is actually we are trying to list out the what? The multiples. So indirectly we are trying to find the what? The lowest common multiple within this tree. We're supposed to find the lowest common multiple within this tree. Okay? So what I need to do, same thing, ladder method. The numbers are 30, 45, and 60. Ask yourself, and all these 3 numbers divided by 2? No, you should divide by 3. That's so it becomes 10. Divide by 3, 15, and 20. Can these 3 numbers divide by 2? No. 3? No. However, they all can divisible by 5. So it's 2, 3, and 4. Any more? No. We are trying to find, remember, we are trying to find what? The lowest common multiple. So next step, any more common factor between these 3? No. We need to concentrate on 2 numbers now. We can take between 2 and 4 there are still common factors, so we divide by 2. So it becomes 1, 3, and 2. If we inspect throughout, between 1 and 3, 3 and 2, and 1 and 2, there's no more common factors, so we concentrate on 1 by 1. Take 3, divide by 3. 1, 1, 2, divide by 2 again, becomes 1, 1, 1. So what will be the lowest common multiple is this thing. So LCM is actually equals to 2 to the power of 2 times 3 to the power of 2 times 5. Okay? Using a calculator, 4 times 5, 20. So that actually is 180 minutes. Which is equals to how many hours? 3 hours. The first ring together at 1100 hours. So when will next time they will ring together again? So just take 1100 hours plus 3 hours. What time will we be? 1400 hours. That's the answer. Okay, can? I give you another question. Next one, you go and try it yourself. Ask yourself, are you trying to find the factors? Are you trying to find an answer that's bigger than these 3 numbers? Or are you trying to find a number that's smaller than these 3 numbers? Okay, if let's say you're trying to find a number with smaller than these 3 numbers, means you're trying to find a factor. If let's say you're trying to find a number that's bigger than these 3 numbers, you're trying to find what? The lowest common multiple. Okay, let's go to the next one. Next one, we'll learn about the numbers. What are perfect squares and perfect cubes? So what are perfect squares? Perfect squares a perfect square means a number which can be square root. It can be square root. Okay, perfect cube means a number which can be cube root. Okay, after you square root a number, after you cube root a number, it becomes what? An integer, which is whole number. So what are some perfect squares? Actually what? 1, 4, 9, 16, 25. Why? Because square root 1 is still what? 1. Square root 4 is what? 2. Square root 3 is actually, square root 9 is actually 3. Square root 16 is actually 4. And then square root 25 is actually 5. That's what we call meant as square root, perfect squares. How about perfect cube? The examples are what? 1, 8, 27, 64, and 125, so on and so forth. Why? If you take cube root of 1, it's still 1. Cube root of 8 is 2. Cube root of 27 is 3. Cube root of 64 is 4. Cube root of this is 5. Okay, so find the solution of square root 1089. So without the calculator, this is what you need to do. First step, we go and prime factorize 1089 first. Express 1089 in terms of prime factors. Can 1089 divide by 2? No. Can 1089 divide by 3? Yes. So write 3 here. 363. Can you divide by 3 again? Yes. Becomes 121. Can you divide by 3? No. So the next prime numbers can be divisible by is actually 11. 11 will be 1. So 1089 will be equals to 3 square times 11 square. So I'm supposed to find the square root of 1089 without using a calculator. This is what you do. We already know that 1089 is actually 3 square times 11 to the power of 2. So what you need to do, replace this 1089 by 3 square. So it's 3 square times 11 square. Now this is the technique. Every time you square root, what you need to do is just divide the powers by what? 2. So the answer will be, just divide the powers by 2. So the answer will be 3 times 11, which is equal to 33. That's the answer. Okay, so how do you find the solutions of 1089 without using a calculator? So the first step is actually go and prime factorize it. Express the number in terms of prime factors, put it in, and divide all the powers by what? 2. That's how you're going to get it. Okay, same thing is the next example. Is actually, you need to work it out yourself. Okay, find a few ticks to example. Take some time to go and work it out yourself and find the answer for me. Okay. Next one, what's a perfect cube? So just I already told you what's a perfect cube. A perfect cube is what? A number which can be what? Cube root. A number which can be cube root. So examples are what? Examples are, just now I already mentioned to you, it can be 1, 8, 27, 64, 125, and then 216, so on and so forth. Why? Because if you cube root all these numbers, it will give you a whole number. A whole number. So same thing, find a solution of cube root 3375 without using a calculator. So the first step, go and prime factorize 3375. Okay, divide by 3 first, becomes 1125. 1125, you divide by 3, it gives you 375. Divide by 3 again, 125. And then you divide by 5 again, gives you 25. Divide 5 again, gives you 5. You divide another 5, gives you 1. Okay, can? So 3375. Sorry. 3375 will just be equals to 3 to the power of 3 times 5 square. 5 cube, sorry. So I'm supposed to find the value cube root of 3375 without the use of the calculator. So same thing, gonna replace now 3375 by the product of its prime factors. Just now when we do square root, we divide the powers by 2. So now if we do cube root, we're gonna divide the powers by 3. We're gonna divide all the powers by 3. So what's the answer? The answer will be just 3 times 5, which is equal to 15. So in short, every time you do square root, means you divide the powers by 2. Every time you do cube root, you're going to divide the powers by 3. Okay, I'll give you another example on the next one. If you took the example, go and try it yourself. Okay, there's a few more examples. I'm going to go through this. Next one, common question in exams. Find the smallest value of x such that 126x is actually a perfect square. It's actually a perfect square. So first step, we go and find 126 first. Prime factorize 126. So it becomes 2, becomes 63. Divide by 3, it gives you 21. Divide by another 3, it gives you 7. Divide by 7, it gives you what? 1. So means what? 126 is actually equals to 2 times 3 square times 7. Now we look at this. Is 126 a perfect square or not? No. How do you know whether a number is actually a perfect square or not? How do you know a number can be a perfect square? We just inspect the powers. Make sure all the powers are divisible by 2. The powers must be divisible by 2. You must make sure all the powers are divisible by 2. Alright, this one clearer. Okay, so now look at 1. Look at the 2 first. This one. This 2 to the power of 1. Is this 2 to the power of 1, right? So is this a perfect square? No, because the powers are not visible by 2. So what must x be? Such that we take x times 126, it becomes a perfect square. X will be 2. Why? Because 2 times 2 to the power of 1 will give you what? 2 to the power of 2, which is then divisible by 2. Next one, we inspect this 3 here. This 3 to the power of 2, is the power divisible by 2? Yes. So do you need to add anything? There isn't. The last one is this one. This is actually 7. 7 to the power of 1. So is this a power? Is the power divisible by 2? No. So what must x be? Such that x times this will give you a perfect square. The answer will be 7. So what's the answer? The answer will be 14. Okay? So I think the most important thing you must know that a perfect square means the powers must all be divisible by 2. Must all be divisible by 2. So what you need to do is actually try to make all the powers divisible by 2. All the powers here divisible by 2. Okay? I give you a next one. You give it a try. Next one, same thing. Now we're going to make 126 into a perfect cube. So first step, same thing. Going to express 126 in terms of prime factors. So write 126 divided by 2. 63 divided by 3, 21 divided by 3, 7 divided by 7, 1. So 126 is actually equals to 2 times 3 square times 7. Okay, so the question wants to find the value of w such that 126w is a perfect cube. So just like we said, perfect square is make sure all the powers are divisible by 2. What's perfect cube? You have to make all the powers divisible by 3. You make all the powers divisible by 3. That's what you need to do. All the powers divisible by 3. Okay? So let's look at the power. This is actually power 1, and then this is also power 1. So what must w be? Let's look at base 2 first. This is just what? 2 to the power of 1. Is the power divisible by 3? No. So what must w be? Such that we take w times this. Sorry. What must w be? Such that we take w times this. Well, we give you a power divisible by 3. W must be 2 to the power of 2. Why? Because 2 to the power of 2 times 2 to the power of 1 will give you 2 to the power of 3. Now let's inspect the next one. 3 to the power of 3. 3 to the power of 2. Is the power divisible by 3? No. So what must w be? Such that we take this times this will give you a perfect cube. The answer will be just 3. Because 3 to the power of 1 times 3 to the power of 2 will give you 3 to the power of 3, which is a perfect cube. Last one, we go and inspect. This one, 7 to the power of 2. Is it 7 to the power of 2? Sorry, it's just 7 to the power of 1. Pardon me. It should be 7 to the power of 1 only. So same thing, is the power divisible by 2? No. So what must w be? W must be actually 7 square. Okay? Can? Using a calculator, the answer will be 38,416. That's the answer. Okay? Can? The next one, I give you a... you can give a try. Okay? I'm gonna do the last 2 examples for you, and then that will be it for this chapter. Next one. Find the smallest integer value of y such that 128y is actually integer. It's actually something the same as this. Because in order to square root 128y into an integer means your 128y must be a perfect square. So you need to make 128y into a perfect square. Same thing, go and prime factorize 128 first. Divide by 2, 64. Divide by 2, 32. Divide by 2 again, 16. Divide by 2, 2 again, 64, 32. Divide by 2 will be 8. Divide by another 2 will be 4. You cannot, sorry, I'm just going to write on the other side, there's too much space. So you divide by 2 becomes 4 again. Then you divide by 2, 2, 2, and 1. So 128 is just equals to 1, 2, 3, 4, 5, 6, 7, 2 to the power 7. Is this a perfect square? No, it's not a perfect square because the power is not divisible by 2. So what must y be such that y times this, such that y times this one will become a perfect square? So the answer is just 2. That's the answer. Okay, next one, same thing. You must, for next question, I'll give you a hint. You must try to make 268x a perfect cube, which means you're gonna make sure all the powers are divisible by 3. Okay, next one, the last one. Find the smallest value of w such that 228 over w, sorry, it should be w, is a perfect square. So the first step, go and prime factorize 228 as well. 2, 114 by 2 is actually 53, 57. Divide by 3 is actually equals to 19. Divide by 19 equals to 1. So 228 is actually equals to 2 to the power of 2 times 3 times 19. Okay? So find the smallest integer value of w such that 228 over w is this. So same thing, what's perfect square? Perfect square means what? Make sure a number which can be square root. In other words, you must make all the powers divisible by 2. But what's the difference? This is actually what? 228 over w. 228, sorry. So means what? You're going to replace 228 by this. So it's 2 to the power of 2 times 3 times 19 over w. What's the difference between this and the previous question? Just now the question was what? Was actually in terms of 228 w. Means you're going to multiply w to 228. But now it's actually 228 over w. Means you need to what? Divide. In this case, you need to take it out instead of putting in. You need to divide instead of multiplying in. So let's go and look at the powers. 2 to the power of 2. Is this a perfect square already? Yes. So we don't go and touch it. Next one, we look at base 3. This is 3 to the power of 1. So what must w be? So you take 228 divide by w becomes perfect square. W in this case will be 3. Why? If it's 3, then you can just cancel and cancel. Then it won't be a problem anymore. How about the next one? 19. 19 is actually here. Okay, so what must w be? So you take this 228 over w becomes a perfect square. Your w must be actually 19. Why? Because 19 and this will cancel. Hence, the perfect square will just be this. So what's w? W is just equals to 57. That's the answer. Okay? Can, so for this question, please remember what's the difference between 228 w and 228 over w. 228 w means you're going to take 228 times w. Means we try to add in. However, we take 228 over w means we try to take it out. Okay? Same thing, the next one will be an example. Okay? And the rest will be your assignments. Okay? All these questions are quite similar to what we did just now. So once you're done with all the try it question, do it all the assignments. So if you can handle everything means you're pretty good for this chapter. Okay? Thank you for your time.